Hi everyone. Today I'm going to be talking about this paper, How to Fight Production Incidents, Empirical Study. Links and slides is going to be on that link, and all the references and all this stuff, and video too. So quick outline following the paper. First we're going to talk about methodology author used to study those incidents. They looked into root causes and mitigation strategies. They looked into delays, what caused those delays in terms of detecting root cause and actually acting on the mitigation. They have some lessons learned, which they analyzed lessons learned from the actual on-call engineers who wrote reports. And they classify those in different categories. And in the end, they have like a multidimensional analysis between all those categories to see like what are the main trends and conclusions, of course. So methodology, where does it all come from? What they do this incidents report? So all the incidents reports come from a single, at least user-facing service, Microsoft Teams. I assume there are more than one service behind that. And they analyzed and studied 152 different reports, looked at their mitigation, root causes, detection, and mitigation approaches. They only looked at the reports which included the complete postmortem report, and they mentioned that 35% more they didn't look at because they didn't have the full postmortem report with all the details they needed for analysis. And even though all of those reports and incidents are high severity, they still, like, there's a breakdown between different severities. There's just one, I assume, very large scale incident that's SEV0. 30% of all the incidents, like 40, 50 of those were SEV1, and the rest of them SEV2, so like less. And any incident included in the study has to impact either internal service, or they mentioned impact several tenants or customers. But I assume impact doesn't mean downtime. It could be maybe increased latency or things like that, or error rate, but still impact. But it doesn't mean it is visible or to all the users, or very negatively perceived, but it's still an incident. So what did they look at? They looked at the root causes. So what is the actual root cause of an incident? And they only assign one category of root cause for an incident. So it's not like where, oh, the code fix caused the capacity issue and things like that. It means it's capacity and the code fix. They only assign, in this case, they probably assign just the code bug being an issue, or just the capacity issue, not two of those. So all those add up to 100% basically. Mitigation steps of what on-call engineers actually performed to resolve an incident. Was it the rollback? Was it the code fix? Was it some kind of added capacity or things like that? How did they detect that? Or what did they monitor? Did it come from users, or what was the what delayed incident what delayed incident resolution? So how, like, why it took longer for an incident to be resolved than everyone would have wanted? So what kind of factors contributed to that? And any automation on-call engineers think is an opportunity to improve future either mitigation or root cause analysis and things like that. So automation is not just one category, it's like across different ones. And overall, the goal is to kind of find what are the lessons to take away from this and how to improve resiliency of the services, in cloud services in general. So as I mentioned before, it is just study of one large service, even though it is, I guess, consistent of many services like databases and other things. But there are some threats to validity. So it is only Microsoft Teams. So if you're running service which has nothing similar to Microsoft Teams, or like as a messaging service, those results they have might not directly apply. Also, Microsoft already has some effective tools and techniques, I assume, testing and like rollout and deployment tools and things like that. So basically, they're very mature in that space. and those already prevent a large amount of incidents. So depending on your kind of maturity level in terms of tools and overall processes of running cloud, you might not see the same results, or might be a breakdown between the causes and effects, and mitigation strategies could be completely different from that. And as I mentioned, they left out 35% of the incidents because the postmortem report did not have all the details it needed. So potentially those might skew results in a significant way, but I assume they don't expect that to be the case. So what about root causes? Basically, the paper kind of presents all the information it presents in those like breakdowns between different root causes, like the code bad is 27%. So it kind of reads a little bit as a statistical report of sorts. So it's maybe a little bit hard to digest. But they also list findings, 15 or 16, I believe, findings where like basically they aggregate them in kind of more narrative way. So in terms of root causes, the major contributors are still code bugs and config bugs. So any kind of configuration change you make, which might cause, even without code change, might cause your service an incident or instability. Some other things is like a dependency failure. So you're using a database, you didn't change anything, and the database you were using has incident on its own. And yeah, they actually categorize database in the network in a separate category, but overall dependency failure is a similar. They mentioned that the database is just because everyone uses a database of sorts. And that's same with network, but overall it's kind of dependency your service relies on. The same, I guess, with authentication. It is a dependency of sorts, but just a reasonably special kind. So first finding in the list is like 40% of incidents, as mentioned here, is either a code bug or configuration bug. But like the rest of them is actually not any of those, which means there are still plenty of errors coming from things you're not changing in your version control. Yeah, so this is just something they observed. In terms of mitigation steps, again, a lot of different strategies. The most popular one being rollback, the first one on the left. Infra change, I think they list specifically what they mean by infra change, and like increasing capacity and things like that. External fix, I think, applies to the some of the service you rely on, dependency. And configuration fix and code fix is a thing you change in your version control and like deploy basically. Ad hoc fix is something like basically what on-call engineer does, some kind of like maybe manual process or something like some twiggling with the system. And transient, the system just restores itself a monitor, like monitoring dipped, alerted you on an incident, and then everything self-healed or something like that. System restored itself. So even though 40% of incidents were caused by code configuration bug, 80% of those were not were mitigated without any code configuration bugs. So I assume because the strategies are kind of faster, they don't involve deployment cycle. That makes, or the same with rollback. Like this is why kind of I think they mentioned it in one of the other findings, where rollback is a popular strategy because it's pretty quick. Yeah, that's the one. The rollback and infrastructure change, because they're quick, they do account for like a 40% of incident mitigation. Just because you don't go through more elaborate cycle of contributing, fixing forward with the code fix or config fix and reviewing it presumably, and rolling it forward or through your deployment system, which takes time. And so another aspect they looked at is delays in response. So basically, what are the causes of that? And one of the main things is that finding number 5 is that time to detect code bugs and dependency is it's hard to detect those because like basically time it takes for people to detect the code bugs is just larger than any other. And I think some of the findings also mentioned that their bugs specifically are hard to monitor. So it's hard to come up with monitoring to find all the various bugs your system might have. And that also makes them complicated in resolution. Yeah, and things like configuration fix and code fix takes longer time. Again, kind of corresponds with one of the previous findings. It's just easier to roll back. Usually, if you can do that, obviously not every system can do that. If you change the data underneath and you can roll back, but large-scale services usually keep that option open for basically any change you can, just because it is so convenient to have options to roll back. I think Alexei has something to say about that in terms of metastable failures and things like that, but rollback is still popular resolution. So detection failures, basically, why did we lose not detected issue incident faster? Things like not failed at all. So like, I guess, I'm not actually sure what they mean by that not failed category. I guess there is no detection except maybe user or upstream system. Other popular ones is like lack of monitors or telemetry coverage, which also causes a delay. So basically, some of the things which indicate that your system is having an incident are just not covered by monitors for whatever reason, or any other telemetry. And that makes it harder to detect and delays any kind of resolution. Mitigation failure threat categories. So like what caused the mitigation to get delayed and fail? These are sometimes related to procedures. So not just systems themselves, but also procedures, which are kind of like part of the social technical system, but not code or anything like that. Sometimes it is just delays in deployment, and a lot of times it's unclear. 27% of the times they just on-call engineers who wrote the report don't know what caused the delay in mitigation, which just kind of tells us that this whole thing is pretty complicated in terms of like figuring out what actually causes those things. Because even on-call engineers who had like way more contacts in the particular incident still don't have enough information to make that call. So yeah, as I mentioned, like 30% of those are not caused by any systems itself, but kind of documentation procedures. This is one of the findings, and manual deployment steps. So there's opportunity for automation, opportunity for improvement, even without changing the code or like, I guess, except the manual deployment, investing in tools. But you can still have improved time to mitigate by changing documentation procedures or improving those. Overall, yeah, lessons learned, basically, this is not what, as far as I understand, this is not what authors like kind of learned from all incidents. This is what they aggregated across different categories of incidents, what actual on-call engineers put in the lessons learned category for specific incident, and then they aggregated them in different categories to see like what are the, excuse me, I need to fix that. So yeah, lessons learned is the main driver is manual test, and so basically testing is still a big theme, and I think it gets even more important later when they mention other findings. So sometimes it's just unclear what the lesson is from the incident. Sometimes they need a test or configuration test or manual test, or improve in alerting, triaging, things like that, automated deployment. So yes, improving testing was a popular choice. So as I said, like testing is important. Figuring out that the system is broken before production is important. But like, unfortunately, paper doesn't go into details like what kind of testing is helpful. There are some other papers which are like focused specifically on incident caused by bugs and how to address those. But that paper is more high level, I guess, and it doesn't go into detail in actually how to improve the testing. It just says like, yes, on-call engineers think that in a lot of incidents, testing and detecting issues with the system earlier in the cycle before it gets deployed to production is important, but they don't talk much or at all about what kind of testing and how to prevent those incidents with specific tests. They basically have just two categories of tests: is regular test and configuration test. Configuration test is also like a pretty vast category and can look completely different depending on what you're targeting. So yeah, overall, improve testing, improve monitoring, things like that. This is like lesson learned category. Investing in automated mitigation, and again, unclear is pretty large category here, 37%. Which means like on-call engineers do not always see the clear lesson from an incident and how to avoid it or mitigate or resolve it faster in the future. So yeah, overall, kind of like 20% of feedback indicated that just behavioral change or documentation training might improve incident management. So this is one of the major categories. So basically you can improve 20% resolution of 20% of the incident just with some kind of better documentation, better incident training, things like that. It could be considered, I guess, less investment than in the systems if you want to build resilience in. The last section of the paper is a multi-dimensional analysis about kind of how all those categories align, basically align with each other. And it is kind of complicated. I think it's not very digestible in terms of presentations, but you can definitely look it up in the paper. They have all those graphs, like what corresponds to what, and like what is the most popular choice, how different categories correlate to each other. I'm just going to present their findings without the data they present in the paper. So as I said, for code changes, people say that improving testing is important, which is kind of hard to disagree with, even since, for example, simple testing can prevent most critical failures paper from 2014, a while ago. But as I said before, authors in here in this analysis, they don't go into details like what kind of testing is actually helpful, unlike, for example, simple testing paper, where they talk into detail and they look way deeper into incidents, and some other papers too, where incidents were caused by bugs, and how to like address those bugs with tests you have. But here is just like, yeah, 70% of incidents of no monitors improve testing rather than monitoring. So monitors for code bugs are hard to build, and it's better to detect code issues even before code reaches production. Yeah, again, monitoring, on the other hand, with the related services should be improved, because like you cannot test your way out of outage in the related service or their misbehavior, but you do because those inherently happen at runtime, at least the ones they found in this study majority. So this is why you kind of need to improve that monitoring and observability coverage across related services. Again, more testing, kind of everyone likes more testing. So configuration bugs mitigated with rollbacks. And these are usually recent changes. So configuration bugs are either they don't, I guess they don't lay dormant for a long time. They either cause incident right away or they just okay changes. So they do talk about that you shouldn't probably invest in rigorous configuration testing, but again, they don't elaborate on what does that actually look like and what are the gaps. Yeah. Incidents with the manual effort and improvements in documentation training are important. Some automation for reducing manual effort, because on-call fatigue was identified as one of the issues here too, which is, I guess, kind of aligned with conventional wisdom. You don't want to a lot of manual steps in any kind of incident management or deployment or things like that, and not at all surprising. Yeah, again, 25% mitigation delay due to manual deployment steps, which is again not surprising, and it's kind of very conventional. So yeah, mitigation steps include automation, like traffic failover and reboot and auto-scaling. So conclusions from the paper, they did look at 152 incident reports, which is a pretty large number of reports over 1 year, from May to May, May 2011 to May 2022, May 2021 to May 2022. They have identified the categories of automation opportunities based on those incident reports. They do have important multidimensional insights from multidimensional analysis, and they presumably will help you improve reliability, even though those are, in my opinion, kind of high level. They don't tell you like kind of more detailed how to, like, on testing your code or testing configuration, how to like actually achieve that, but it's still valuable information. Or like things like improving documentation. Obviously, like I guess it's going to be pretty hard to figure out what, especially in general terms, what kind of documentation needs to be improved. Actually, Microsoft Teams has a outage today, or like last night, whatever. It happens right now. So this is the tweet from like a few hours ago. They rolled back a network change, and I kind of just saw that before the talk, and it was interesting to see what they're doing. And apparently they kind of doing the same things they talked about in the paper. So they did roll back the change. So it is the most popular mitigation strategy to just roll back the thing. And the database network is not the most popular root cause, but it is definitely a separate category in there. So kind of like was interesting to I don't know, analyze based on very limited information in the tweet about what's going on. And they're saying that the monitoring, so monitoring again mentioned as one of the important things to resolve issues and resolve incidents and see how like systems doing. Yeah, that is it. Everything I wanted to say about the paper. Thank you.